My name is Brandy Tilkis, and this is my student conference video over 1.10 through 1.16. The first question says, let f be the function defined by, and then this here. So we're trying to find out if there is a limit there. So the first step is we're going to have to plug in 2 for both of these two equations right here and here. So to begin with, we're going to plug the 2 in for f of x. So sine of 2 is equal to, and then so that is 0.903. So we're going to write that in here. 0.9093. And then we're also going to plug in the 2 for the 0.5. So we're going to go ahead and do the sine of 0.5 times 2. And that is going to end up being all right, so it looks like it's going to be 0.8415. So because these two numbers do not add up to the same number, then it looks like we will not have a limit because they will not equal each other. So on the graph, the lines will not meet. For number 2, it is asking where f is not continuous. So the first thing we are going to have to do is to factor both the numerator and the denominator. So in order to factor this, you got to do x plus 3 and x plus 2, because when you FOIL that, that is what you end up getting. So go ahead and do that, and then for the bottom, it will be 2x plus 1 and x plus 3. So in order to do this, we're trying to figure out where so the denominator cannot equal 0. We know that. It is illegal. So we're going to have to cross cancel in order to find the point of discontinuity. So I pulled up the graph right over here as well. So this is the point of discontinuity. It is at -3. And if you line it up perfectly, you see that it is undefined. So after you cross out the x plus 3's, then you get x plus 2 over 2x plus 1. So knowing that the bottom cannot equal 0, we know that we're going to have a vertical asymptote. So you're going to go ahead and do 2x plus 1 equals 0 to try to find that asymptote. And minus the 1, 2x equals -1, divided by 2, x equals -1/2. So as we can still see on the graph, we have a vertical asymptote at -1/2. So we can see that at x equals -3, we have a POD, a point of discontinuity, and then we have a vertical asymptote at -1/2. All right, for the next one, it says that we are trying to find the height in meters of an object after it has fallen a certain amount of seconds. So 8 and 9 are going to be our seconds that we're going to plug into this equation. So we're going to go ahead and go -4.9 times, we'll start with 8 squared plus 396.9 in order to find how many meters in the air it is. So go ahead and plug that into our calculator. So -4.9 parentheses 8 squared plus 396.9, and we're going to go ahead and get 83.3 meters. So we can tell that that is obviously in the air. So now we're going to go ahead and plug in 9 for this equation as well. So the 9 squared plus 396.9 is equal to, and we can go ahead and just get the calculator again and plug in the equation, and then just change the one number to 9 instead. And as we can see, we got 0 from that. So at 9 seconds, we can see that is 0 meters in the air. So then we're going to use this equation right over here for the average rate of change. So we see that S9 is this equation right here, because this is where we plugged in 9. So you're going to go ahead and go 0 minus, and then this number that we got it from plugging in 8. So 83.3 divided by 9 minus 8. So when you do that, you go ahead and get negative 83.3 over 1. So we see that the rate of change from 9 seconds, or from 8 seconds to 9 seconds, is negative 83.3 meters per second. And there we are. That is the answer for number 3. All right, for number 4, it is asking what algebraic technique can be used in order to determine if there is a limit or not. So right away, if we try to plug in 1, we'll get 0 in the denominator, which we cannot do. So my first thought was to use the conjugate. So in order to do that, it would be the square root of x plus 1. So it would be x minus 1, and you do that to both the numerator and the denominator. So it would be x plus 1 parentheses square root x plus 1. And then in the bottom, you would do that again. So you would have the original square root x minus 1, and then multiply that by the conjugate square root x plus 1. So when we do this, then we can go ahead and, so we're trying to get rid of this. This is the real problem. So we're going to go ahead and FOIL, and when you do that, both this piece and the O and the I crosses out. So we're going to get x minus 1, and then multiply that by the x plus 1, the conjugate, and then that's all going to be over another x minus 1. So once we get to this, then you can go ahead and cross out the common factors. So you can cross out that, so it's going to be square root x plus 1. And then you can go ahead and plug in your number. So square root of 1 plus 1. And the square root of 1, as we all know, is still 1. So the limit is going to actually end up being 2. So limit as x approaches 1 of x minus 1 all over square root x minus 1 is equal to 2. And that is number 4. All right, for question number 5, it says, which of the following limits do not exist? So in order to figure out if a limit exists or not, you have to take it from the left side of what the x is approaching and the right side. So for example, we're going to do 0.0 or 0.999. because that would be on the left side of the 1. So if we go ahead and plug that in, it would be 0.999 cubed plus 1 all over 0.999 minus 1. So when you do the math for all of that, you end up getting 1.997 over negative 0.001, which is equal to negative infinity, because of the one of the sections talks about how if the number on the top is larger than the number on the bottom, then it's to negative infinity. Okay, so for finding the right side, we're gonna have to take a number that is greater than 1. So we're gonna do 1.001. And then cube that plus 1 all over 1.001 minus 1. When we get that, you're going to get 2.003 all over 0.001, which is equal to positive infinity. Because these two do not equal the same thing, there is no limit, so does not exist. We can count this one as one that does not exist. Alright, so we're going to do the same thing for this second problem on number 5. So the absolute value or the bars are telling us that no matter if there's a negative in this or not, it is going to be a positive number. So looking at a number on the left side of 0 would be negative 0.001, let's use. So since we see here that it's the absolute value bars, it's going to be, so if we use a negative number, it's going to be the positive of that number over the negative of that same number, which is going to equal -1. And then if we're going to use a number on the right side, so for example, 0.001, it's going to be the positive number over the same number that we already plugged in, which is going to equal +1. So again, does not exist. The two numbers, when plugging it in, does not equal the same thing, making it so there is no limit at this 0 point. Alright, for this last one, we are seeing if there is a limit at x is approaching 2. So if we insert 2 into this equation, we see that the f of x, so then you would have to go over to where the 2 is. So this one says less than or equal to 2. So if we insert 2, we're going to go ahead and get 3 if we try to get it from the left side. So, for example, like if we used negative, or not negative, 1.999, we're going to go ahead and get 3. And then for this one, if we did one that's on the right side of 2, so anything larger than 2, so 2.001, then we're going to go ahead and get 0. So unfortunately from this, we're going to see that it is another usable limit. It does not exist. The two sums do not equal the same thing. So it looks like both or all of 1, 2, and 3 are limits that do not exist.